Okay, can everyone hear me? Ibrahim?
Yes.
Okay, so let's come to, I want to open up the chat window and I'm going to share with everyone here a file. This should be a quick one, I hope, to go do. So check your chat window, double click this file that I just sent in the chat window. And it's called BC Boolean Ops. Let's double click that. And this is the problem I have. I'm going to put you all into groups. Don't start coding this right now, please. So a lot of times we go into groups and some people who just were motivated had already started coding it. No, we want to code it together in your groups. So here, write a program. It's a pretty straightforward program, pretty short. Ask the user to enter a number, and then you need to print out if the number is divisible by 2 and 3, by 2 or 3, or also if it's divisible by 2 or 3, but not both 2 and 3. Okay, so again, I don't want anyone coding this yet. So here, if someone enters 18, you should print 18 is divisible by 2 and 3, because it is divisible by 2 and 3. You should also print 18 is divisible by 2 or 3, because it is divisible by either 2 or 3. And then here, you're not going to print that it's divisible by 2 or 3, but not both. You won't print that line because, in fact, 18 is divisible by both 2 and 3, so it won't print the 2 or 3, but not both, right? And make these, how about you make these as 3 individual long if statements. Don't do any elif. We want to practice this, okay? And then look at the same thing for 15. 15 is divisible by 2 or 3. In this case, it's divisible by 3. And then you're going to also print 15 is divisible by 2 or 3, but not both. Okay, so we want to have, your code should be 3 individual if statements, but it's going to be compound if statements using these logical operators, ands and ors that we just covered. Okay, so if something, print the integer is divisible by 2 and 3. If something else, print the integer is divisible by 2 or 3. And then finally, if something else, print the integer is divisible by 2 or 3, but not both. So let me make the breakout rooms. Give me just one moment. And this looks just fine. Pardon me.
So who wanted to share?
So who's sharing? What's going on?
I guess I'll share.
Thank you, David.
All right.
Now, David, are you and Sean related?
Yeah,
Yes.
we're actually in the same room right now.
Gotcha. Okay.
So he's going to try and be mute because then a very loud, annoying echo occurs.
Sure. Who's the older of the two?
Obviously me.
Obviously you. I haven't seen either, so I don't know.
You can just tell.
Just by the name?
Just by our voice.
But have I heard Sean? I don't know if I've heard him.
Exactly. All right, so we have enter an integer, and we have to check if it's divisible by 2 and 3, 2 or 3, and by 2 or 3, but not both, correct?
That is correct. With 3 individual long if statements. I'm not trying to make it too fancy. The whole purpose is to practice the Boolean operators. So just 3 individual Boolean, individual if statements with Boolean expressions and using the logical operators. So,
All right.
Colson, are you there? Can you hear us?
Yes.
Can you help out some?
Sure.
So what does he type?
If num is divided by 2 or 3.
So how do we check if it's, what do you mean by divided by 2? How do we check that? So when we check for divisibility, if we want to know, is num divisible by 2? What does that really mean in mathematics?
We can do mod 2, and if it has a remainder, it won't be divisible by 2.
Perfect. Because in mathematics, if something is divisible by 2, any number, if I say that x is in fact divisible by 2, what that really means is there is no remainder. So you're correct. We're gonna mod num by 2 and then check if the remainder equals 0. Perfect.
And you'll do that to 3 as well.
Perfect.
So if num mod 2 is equal to 0 or num mod divisible by num mod 3 equals 0, because then it's divisible.
Yep.
Where's my mod operator? There it is.
So if that equals 0, and notice that's the or, okay?
Oh, whoops,
and
thank you.
Well, you need to do the or as well, so it doesn't matter the order that you do them in. So whatever you like. Cool. I'm gonna go check another room, see if everyone's proceeding correctly. And do we all understand how Chloe? Liz Chloe, right? Yeah. How Chloe is checking for the divisibility? Jonathan Musab.
Yes.
Cool. Because as y'all know, I shouldn't make this clear, even I think it's already very clear, but what does divisibility by 3 mean, Jonathan, in mathematics?
Divisibility by 3.
Yep, if a number is divisible by 3, what does that really mean?
It doesn't have any limit.
Yeah, that's exactly it. That when whatever the answer is up here doesn't really matter. If it's divisible by 3, it simply means that there's no remainder. And so that's what y'all are doing. You're checking the mod, the remainder. Cool, that one works. So that was checking for and so now you need to go check for or, and also to make sure not both of them.
No. So you don't want us to do an else if?
No, I don't want
Any
any else's, just 3 individual if statements.
Okay.
And if you did, Chloe, an else, you would have seen that you wouldn't have gotten the exact output, because remember, once the if is true, you won't do the else. But on the picture I sent you, you actually want to print every statement that it matches up with.
Oh, right. Thank you.
You are welcome. I'm gonna go check on the last group. Cole, is it working?
It is.
Rebecca, do we agree?
Yes. Yeah.
If num1 is divisible by 2 and 3, and as I mentioned, you'll see in anyone who watches the video back, you'll see this. I just wanted to confirm. What does divisibility mean in mathematics if we say that some number x is divisible by 3? What does that really mean?
Cleanly divisible.
And what
No
is,
remainder.
and you said cleanly divisible, and I think Rebecca said there's no remainder. So the remainder should be 0, which is in fact why you're checking the mod. Nicely done. So let me just see someone. I don't know. It said that someone was waiting to be assigned to a room. So cool. Ibrahim, very quickly, if you can share yours when we get back. All right.
Yep.
Thank you. So go ahead, Ibrahim, and share yours, please.
Coming up. And y'all can see this?
So here, can you explain what you did?
Right. So we got a number from the user. Then first we checked if it's divisible by 2 and 3. And by divisible, as you said, as we said, it's cleanly divisible, meaning no remainder. So if they're both divisible, if they're divisible by 2 and 3, we tell the user so. If it's divisible by 2 or 3, we print so. And then here was the complicated one. If it's divisible by 2 or 3, and it's not divisible by 2 and 3, meaning it's only divisible by one of them. So it can't be divisible by both. I'm not sure how to close that.
Yep, no, so do this. I want everyone, that was clearly explained, but I want to add a couple of comments to it. Really, I'm just going to repeat what you stated, because you stated it perfectly. So I want to repeat it and then give everyone a chance to process that entire. Can you click enter like 10 times after that red dot?
Oh. Okay, hold on a second.
After the red dot. Just to put some space so I can draw in there. Keep going. That's good.
Also X this out
Yep.
so you can.
Yep, that's good. So here, within here, examining that entire statement, we're really saying, is that whole thing true or false? Yikes. So you have to really think about what's going on there. Well, there's really two big statements, that one and this one, but it's really the not of this one. And those two statements are anded. It's a great arrow. They're anded together. Those two statements are anded together. So now let's look at what was the number 15. So 15 mod 2 equals 0. Is 15 divisible by 2?
No.
So this right here is false. Is 15 divisible by 3? Go ahead,
Yes.
Ibrahim, you can say it.
Okay,
I don't know if anyone, maybe people think I'm just asking you. So let me put the 15 is not divisible by 2, but it is divisible by 3. So I'm gonna put both of those answers in there. So now let's look at this. False or true? What's that result in? False or true? That's true. Now let's look at this expression over here. We have false and true. Now false and true is going to be what?
False.
Just keep it unmuted. That's false. So now we have a true here. We have a false here. Okay. And we have, but this second false that I have right here, in fact, it's supposed to be a not false, right? So if I come and I put a not right in front of that, what we're left with is we have true and what is a not false? True. And then true and true is in fact true. Okay, that's a detailed explanation of that. So yeah, but this entire line 8 succinctly captures, maybe not succinctly, but yeah, I mean, it captures clearly what we were looking for, where it says test, are they both divisible and not, no, test if one of them is divisible, either this one or that one, and not both of them. So that is a direct translation of what was being asked into English. So now I want to end by asking, on the end of this question, by asking, give me a thumbs up if you understand this example perfectly and the code makes sense. You can, I'll go ahead and stop your share. So if y'all can put that in the participant window, please. Sean, are we okay? I don't know. Sean and Imran, we don't have thumbs up, so it's okay. So I'm not sure, but Sean did put his thumbs up. Cool. So we hopefully, for the most part, understand that example. So let's move on to the next one. So this was, what is this? This is the solution that I put online. So what did we have here? Yeah, notice that that last statement, this is how you just wrote it, Ibrahim, how your group wrote it. And it could have also been written this way. Check this out. It could have been written that way. I could have said, if the number is divisible by 2 or 3, and is the number not divisible by 2 or not divisible by 3. Does that make sense logically? That's the exact same logical thing. Is the number not divisible by 2 or not divisible by 3? That's the same exact thing logically. Okay. So, and in fact, that's a rule. I'm not trying to go teach you, again, discrete mathematics at the moment, but if you actually have, where can I write this so you can see? If I say not P, what is it, and? You had and inside, right? Yeah, not P and Q. So P and Q are two statements. That not P gets distributed. It's like almost like distribution in math. So I'm going to say not P, and it gets distributed to the Q as well. So this is going to be not Q. So this not right here, it's like distribution. It gets distributed here and here. But then what happens is it's a special rule that and flips to an or. Again, that's not something we're really trying to study right now. But since we're on the topic, I figure I'll throw that out to you. And that is a special rule. It's called De Morgan's Law. And if you happen to review these, the PDF, which is online, you'll see that it's mentioned right here. So cool. Let me click that slide. If everyone can unmute your mics, as long as there's no like major background noise. Unmute. Chloe, Sean, Mariam, who else? David, Jonathan. We can unmute. Colson. Yep, let's unmute. I want y'all to just tell me the answer as soon as you say the answer. Assume x is 1. What's the result of the following? X is 1. What is the result of the following? The first one. Just the first line. True and 3 greater than 4. There's no x. What's the answer? That's false because we have true and, well, 3 greater than 4. That's a false, right? So true and false is false. Okay. What about the next one?
False.
False.
The next one you're saying is false. Why is it false? Someone other than Ibrahim.
X is greater than 1, but there's a not, and given that it's an and statement, that will make it false.
And you know what? That's worth actually pausing and explaining more, because here, as you said, is absolutely correct. X is greater than 1, so all of that becomes true, but not true is false. So what if I were to tell you, so you tell me if the following is true or false. 5 is greater than 2, and the triple integral of blah, blah, no, hold on, I've said that wrong. 5 is greater than 10, and the triple integral of blah, 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 blah. What's the answer?
False.
Because we don't care about what comes next, because I just told you, I started by saying that 5 is greater than 10. I said 5 is greater than 10, and the triple integral of something. You're like, whoa, I haven't studied calculus. Okay, so you should realize that something should have been up with my question. Because the first thing was already false. All of this was already false. And we have an and right here, right? We don't even need to look at this thing right here. You don't even need to look at it. In fact, that's exactly how an interpreter of Python works. If you say false and then whatever you put here, you can put 1,000 statements right there. Python won't even look at it. You understand that? You can put whatever you want. Python won't even look at it. With that in mind, let me ask you something. What would be another statement, Chloe, that you might think Python will not even look at? I'm gonna erase all of this. What would I put here and here such that Python will not even look at that? I just told you if I had put false as well as an and, Python won't even look at this. What's something else I can put here where Python may not even look at, Chloe?
True or.
Perfect. Perfect. Nicely done. If I say true or anything right here, Python does not even look at that anything. Because whatever you put there, you're going to have the total answer is going to be true, because true or anything is true. False and anything is false. Nicely done. So let's see. That was going to be, I think David had said, false. Correct. What's the next one?
True.
Explanation?
X is greater than 1, and it's an or statement, thus we don't even need to look at the rest.
Perfect. True. Okay, what's the next one? Shout it out. Anyone?
False.
Yeah, as soon as you know it, shout it out. Next one's false. Why?
Because X is 1, so it's not 0. I'm sorry, hold on. I just messed up there big time.
You did.
True.
Okay. Why?
Because X is not equal 0 and X is 1. So 1 is not equal 0.
1 does not equal to 0. So that is a true statement. We don't even bother looking at the right of the or. Okay, the next one.
True.
True. Rebecca, great. Why?
1 is greater or equal to 0.
And therefore, we don't even look to the right of the or again. And the final one, what is this one?
False.
You got to go slow.
What's up with that equal there in the middle?
That's an equal. So an equal is comparing two things, right? So let's look at this. X starts at 1. So 1 does not equal 1. What's the result of that, Rebecca?
False.
That's false. Now x equals 1 over here. So 1 equal 1. What's the result of that?
True.
That's true. Now not true is false. And so now if I say false equal false, is that a true or false statement?
True.
True.
That's a true statement. That was an interesting one. Okay. So those are all just good practice. Now you might wonder, because we're doing less coding today, as you see. Why? Because we have to go through this logic. This is very important. All of this logic of Boolean expressions with these connective logical operators, you use them throughout programming, okay? So someone tell me, write a Boolean expression that evaluates to true if num is between 1 and 100. Anyone just tell me how do I actually type that up?
If num is greater than or equal to 1, and if num is less than or equal to 100, print true.
That's it. Perfect. That is exactly it. Nicely done. Okay. So here, that would be our statement. Okay. I went ahead and put the if in front because you stated, but yeah, that's our statement. Num greater than 1 or equal. I didn't say inclusive or not. That's fine. Either way, it's correct. Write a Boolean expression that evaluates to true if the variable num is between 1 and 100 or if number is negative. Someone else give me that one. Chloe, possible?
So you would just repeat what you said at the top and then just say, or num is less than, or sorry, just less than 0.
Perfect. Perfect. So, and notice I put an extra pair of parentheses just to glue all that together. So here we have this outer pair. So here, num is between 1 and 100 or num is less than 0. Okay. So being able to take what's in your mind and translate that into a large Boolean expression using these logical connectives, these operators, is very important. Write a Boolean expression that evaluates to true if weight is greater than 50 or height is greater than 160. Jonathan, can you help?
If weight is greater than 50 and weight is less than 160,
What does it say?
oh, greater.
Oh, this weight and
Or-
height.
I see, yeah. I see it. So if weight is greater than 50 or weight is greater than 160.
It was height, actually.
Height,
But
oh.
really, that just really amounted to reading it, right? Which you did. Ultimately, you just read it, and it's just really what's in English translated. How about this one, David? Write a Boolean expression, evaluates it true if either weight is greater than 50 or height is greater than 160, but not both.
So if weight is greater than 50 or height is greater than 160, so the top one, but not both, you would then do the close that. Crap, I lost my train of thought.
Try it again. No issue. Try it again. You're good. You gonna try it again, David?
I'm thinking, for some reason, I can't figure it out. I just
No
had
issue.
it.
That's okay. Rebecca?
Am I unmuted?
Yes, you are.
Okay, good. I'm sorry.
You want to try this one, Rebecca?
Okay. If weight greater than 50 or height greater than 160. Oh wait, hold on. Okay.
Yeah, this one's not as easy to go throw out. Ibrahim, you want to try it?
Sure. If weight's greater than 50 or height's greater than 160 and not weight greater than 50 and height greater than 160.
And what made that easy maybe for him to do is a variety of things, but including the fact that that's what he just coded up earlier, right?
Yep.
That's the exact one for the, what was it? The 2 and 3 divisibility. So, but not both. So if they're both divisible and it's not the case that so if one of them is divisible and it's not the case that they're both divisible, right? So here it was true if the weight is greater than 50 or the height is greater than 160, but not both of them. So it's true right here. Bear with me, I'm trying to get my pen back. Annotate, pen. So It's true if one of those is correct and not both of them. So hopefully that covers that. But so you can see there's some thought involved. It looks easy, but no, you have to really think about it. So this program here, I don't think it's the best example, so I'm not going to go through it in detail. I mean, the whole purpose of this one particular example is just to practice Boolean expressions, which we just accomplished. This is now showing, well, here's a real life example you could do. It's not the best one. It's in the textbook from the publisher. Leap year, as you know, leap year is every 4 years. You just really need to know the rule for leap year. So a leap year, most people think it's just every 4 years is the rule. Well, it's actually a little bit more complicated than that. The rule is, as you see there, a year is a leap year if it is divisible by 4, but not 100, or if it's divisible by 400. So the year 2000 was a leap year, okay? To be clear, the year 2000 is a leap year. Therefore, 2004 is a leap year, 2008 is a leap year, 2012, 2016, 2020 is a leap year. The next leap year is going to be 2024. That's going to be a leap year, 2024. Okay? But, so let me write that a little bit more clear. 2024 is a leap year. But the year 2100 is not a leap year, even though it's divisible by 4. The year 2100 is not a leap year. That's just the rule. And this rule came up with mathematically just because we know that how many times, what is the 365 days? What does it represent? Science, quick. It's not a science class.
The amount of time it takes for the Earth to revolve around the sun.
Right, 365 days and a quarter, right? And mathematically, how do you actually accomplish that? It's actually, we say a quarter, it's not that exact. Otherwise, it would be, in fact, every 4 years. But the way it works out mathematically is every 100 years is not a leap year. And so 2100 is not a leap year. 2200 is not a leap year. 2300 is not a leap, excuse me, it's not a leap year. But the year 2400 is a leap year. Because the rule is a year is a leap year, it's divisible by 4, but not 100, or if it's divisible by 400. So the only purpose of this example was to practice using a more complicated or convoluted expression, which you see there. And so here's the actual code. You ask a user, enter a year, and then we made this variable. I made a Boolean variable, is leap year, which I set to be the result of this expression. Because remember, someone just shouted out, what is this called that I'm pointing to? What is that called?
Assignment operator.
That's an assignment operator. Perfect, Rebecca. Which means we're going to start on the right of that assignment operator, and we're going to evaluate that. And all of that is going to evaluate to either true or false. And then we're going to take the result of that, and we're going to save it into this variable is leap year. So the whole purpose of this problem, it's not the most exciting one, but it's just to really practice coming up with applying that rule and how do we come up with it. So the rule was if the year is divisible by 4 and the year is not divisible by 100, which is what that shows. That's why we have not equal to 0, the mod, meaning there is a remainder. So it's divisible by 4 and not divisible by 100, then it's a leap year. Or regardless of all of that, if the year is divisible by 400, it's a leap year. That's the actual mathematical rule for determining leap years. So that's not the best one. So I don't want to break out into groups just to solve that. But this one is worth doing. So let's see, how much time do we have left on this one? I think we got about maybe 8 to 10 minutes possibly. I've not got the notification saying only 10 minutes left. So write a simple lottery game. Let's pretend you don't have to pay for this. It's just, yeah, it's a raffle. The meeting will end in 10 minutes. So we got the time. I got a prompt just now. Your program should randomly generate a 2-digit number. And again, please don't start coding this. Your program should randomly generate a 2-digit number. You should prompt the user to also enter a 2-digit number. And you need to determine winnings based on this awesome formula. So imagine if the user input matches the lottery in the exact order, they get $10,000. If the user enters the digits, but it doesn't match, but it's in reversed order, okay? So if all the digits in the inputs and the user's input match, but they're not in the correct order, they win $3,000. And if only one digit matches, they win $1,000. Let's look at this for clarity. Let's just say, so you randomly generate a 2-digit number. Let's just say the number generated is 74. If the user enters, and then you ask the user, enter a 2-digit number to see if you win. Well, if they enter 74 by chance, well, guess what? They get $10,000, and you should prompt them, hey, you win $10,000. If they enter the number 47, that is not the correct number, but both of the digits actually match. Does that make sense? Both of the digits match. So therefore, they will win $3,000 because it's not the correct number, but it's in reverse order. And then finally, what if the user entered 17? They're going to win 1,000 because one of the digits matched. Or what if they enter 70? They win 1,000 because again, one of the digits matches. Or another set, they could have entered 42, and again, one of the digits matched. Or they could have entered 24, and again, one of the digits matches, and they win $1,000. Okay, so this is an explanation. And the random number, it should be a 2-digit number. So make sure the number is going to be between 10 and 99. Okay, a 2-digit number between 10 and 99, and the user is going to enter a number between 10 and 99. So we need to determine if it's the exact number, they win 1,000. I'm sorry, they win 10,000. Else if all of the digits, they're the correct digits, but in reverse order. So you have to think about how do you do that. We've done some replets, right? Where if you have the number 74, I think all of you by this point know how to get just the 7, and you know how to get just the 4 by using mod and integer division, okay? And then once you extract the individual numbers, we need to check, do they possibly win 1,000? Otherwise, like, wow, like you can just tell them like you just are horribly, not good at these type of things. So let us try to go to breakout rooms real quick. Let me first actually see, bear with me. Clear all, stop. And you know what? This won't take too long, but I want to have this actually give us about 10 more minutes. So I'm going to stop share, end this session, and then come back for about 10 minutes. We have 6.5 minutes on the session. I think we might need like 3 more to give you all a chance to fully code this. So I'm going to end the meeting and come back for one final session.